Hi, amazing AP Physics 1 students. In this video, I'll pinpoint main ideas from the Unit 3 Day 1. So we started Unit 3 today, and it's about circular motion and gravitation. Woohoo! I'm super excited about this unit. So what you have to take away from this unit is that it's super short. We only have 2 classes this week and 2 classes next week to finish the unit. I know it is crazy, but I hope we'll do well, and let's begin. I'm going to skip this slide because it's not essential, but you're welcome to go back into the slides and look into this. So we reviewed the assigned videos. The 3.1, 3.2, and 3.3 videos were assigned to you. These were the topics associated with the videos. Before we reviewed the videos, we were introduced to the Newton's universal law of gravitation. That's an amazing law. We talked about thought experiments, how Newton had this revolutionary thought that the reason why moon moves around Earth and planets move around the sun, and the reason why apple falls from a tree is the same reason. It's the same force behind those different motions that no one before him, as we know of, thought of. So, and he also came up with this mathematical relationship that the force between two objects with mass is proportional to the inverse square of the distance between the center of masses of two objects. So G is the universal gravitational constant, and it is super small. It was really a great part of history of physics to measure this constant. So Cavendish was a British scientist, Lord Cavendish, who actually figured out the experiment because it was very difficult to set up to measure it precisely, because it's a super tiny value. You see, it's 10 to negative 11th. As a result, gravitational field is another concept. That's another equation from your reference table. So G, we already know what G is. It's 9.8 meters per second square acceleration due to gravity, but it's a gravitational field. It's the force of gravity divided by the mass. So if you plug it into the formula here, you can get the G for Earth is universal gravitation constant times the mass of the Earth divided by the radius squared, where the radius, where the R is the radius of the Earth. And factors of one method, that's what you watched in the video, and we answered these 4 questions. And please watch the video if you don't know what the factors of one method is. So questions, this is how we reviewed the video using the paired deck. Now we introduced this new concept, centripetal force intro. Wow, it's a very cool concept. So we asked this question and we look at this video. If you click on this video in your slide presentation, it's a very short video, but you have to answer the question. So what direction were the students pushing on the ball with the broom? And the answer is towards the center of the circle, right? Then you would have to go to this link and open this amazing game. This is a game. You have to make a race car go around the track, but you have to direct the force vector. And eventually, after multiple unsuccessful trials, you'll figure out that the direction of the force vector has to be towards the center to make the car turn into a curve path. So uniform circular motion, why we say uniform? Okay, so linear speed or tangential speed, which is tangent to the circle, is constant. What does it mean? It means that the value or the magnitude of the vector doesn't change. However, the direction of the vector changes. Due to the change in direction of the vector, we have a delta v, which is the acceleration and which is directed towards the center. So centripetal acceleration is delta v due to the change of direction is v squared over r, right? R is the radius. And centripetal force must be present. If you have acceleration, you should have unbalanced net force. So we call it centripetal force. Centripetal means center seeking. It's also directed in the same direction as the acceleration, because it's the net force, unbalanced external force that is causing the acceleration. And it's mv squared over r. However, centripetal force is a type of force, not a force in itself. That's very important. It should not be shown on free body diagram. So for the car, when the car is turning, making a turn, right, the centripetal force is the force of friction, because the road pushes on the tires, right? There is a friction between the tires of the car and the road that keeps the car in place, that makes it possible for the car to turn. When you have planets, it's the force of gravity. The force of gravity is the centripetal force. When you have an object on a string, you're rotating it on a string, is the force of tension. So it can be a combination of forces, but it's not a force in itself. Okay, period is another physical quantity, is the length of time required to complete one revolution. So we'll have a different formula for period later on in the course, but for this purpose, we're using this formula. It's capital T equals 2 pi r over v. So it makes sense. 2 pi r is the length of the path, is the circumference, and divided by v, because v is a constant speed, right? So tangential acceleration, well, that is a case when the magnitude of the velocity is not constant. So if the circular motion is not uniform, which means that the magnitude of velocity is changing, then there is a tangential acceleration. Sorry, I didn't finish writing the slide for some reason. So, and one more fun part of this presentation is the geosynchronous orbit. That's a really cool thing. It exists. It's very useful and practical for communication. A lot of satellites are in that orbit. So what it is it's an orbit at which the period of the body is equal to the period of rotation of the Earth. So basically, you have a satellite above the Earth that is rotating with the same period as the Earth. So it's basically stationary above the same point above the Earth. But the length, the radius of this orbit is really big. It's really far. I don't remember exactly the number, but it's much farther than ISS or Hubble telescope, right? Much farther. So Google it up and see. But we can now calculate it. We can calculate it because we know the force of gravity is the centripetal force, and we can calculate the radius. Oh, I mean, not the radius, but the distance or the radius of that satellite, which is super cool. But after the brain break, what we started doing, we started working on this 4 workbook problems. The 2 problems are for gravity, and the 2 problems are for circular motion, and we'll finish next class. So this is all you need to know for this class. The presentation will be done next class, and this is the homework. The homework is also posted on Google Classroom, so please do the next 3 videos. Watch these videos, they're super fun. Read the textbook. Study the misconceptions, try to refute all of them, and watch this fun video about the Space Odyssey, because there is so much material for this unit and I'm so excited to share it with you, but it's super short, so please do the work and come to class prepared. Thanks for watching.